Okay, we're continuing on at our first introductory lecture on machine learning, and we had this deep, gradually going deeper into the areas of what we're referring to, artificial intelligence, subset of that is machine learning, and then we have a subset of that as deep learning, and we talked about this. And then let's get into analytics and data analytics. And so the term analytics is commonly used in business for data-driven analysis for decision making. It is a general term applying analysis techniques to the data to solve problems. It is not a technology itself, but a group of tools. So that might be something to remember, used in combination. The purpose is to gain information, analyze information, predict different possible actions, quantify the effects of the possible future decisions on business optimization. Then going beyond that, instead of just data analytics, think about big data analytics. And this is where we're scaling to complex, extremely large data sets. It gets into more in terms of volume, variety, and velocity. And this is probably one of the most debated current research issues in how you can best analyze large data sets and unpack the interesting details that are there. So once again, thinking about our course focus, and so we have a changing landscape. Technology is constantly changing, computation capabilities improve, data mining exists on a shifting landscape. What are the best strategies and algorithms? And so those are always going to be refined. And not only is the old part being defined, but new areas of interest always loom. There can be new areas of data that we're going to be doing data mining and things like that. So our focus in this course is the foundations of machine learning. Let's make sure that we understand what these techniques are before we get a chance to start thinking about them in terms of a black box analogy. So here is a listing from the textbook of applications for machine learning. So it is well worth the time doing the read. So go ahead and go through that information. I'll just give a few comments that I picked up in terms of what the motivation for each of these areas. The first is machine vision. So we can be taking some scenes that have been recorded and start to analyze them and pull out some details based on some criteria that we could be leveraging, maybe looking for a certain type of vehicle, a certain type of vegetation. Those would be possibilities. Biometric recognition, how can you quickly and effectively have different type of biometric data, whether it be fingerprints, facial scans, gait of a walk, range of motion for a limb. It can go on and on and on. Handwriting recognition, how you can be determining when an individual writes things down, whether it be an envelope that's being sent in the mail or a text, the letter that's handwritten, all of that would fall into that category. Medical diagnosis, this can be an augmentations for physicians where you get a certain set of traits, and instead of having to memorize all of these books about this trait means this kind of a diagnosis, you can get these augmentation aids. You can also be doing genomics, DNA research, by looking how you can be doing alignment of biological sequences. The way that you actually come up with a genome is actually using a process like that. You get little bits and you start to put it together like a puzzle. You can be using machine learning for drug design. You may have a couple of possible drugs, and so which performs better based on the pathology that you're trying to target. And so you can have various types of possible candidates and play them in realistic types of scenarios. So we've had biometric recognition, handwriting recognition, and yet another one would be speech recognition, is where you're trying to interpret speech. And so you can be thinking about a voice to text type of scenario. And it can go a lot deeper to recognizing if this is a specific individual. That would be higher tier of possible type of analyzing you're trying to do. Text mining, you can have a lot of different documents that you're trying to find different types of topics, different types of semantic meaning, going a little bit further rather than just a keyword search. All of that can be done with machine learning. You can do natural language processing, looking at the way that the words are connected to one another. You could be looking at audio streams, video sources, and then start to annotate, create metadata with those different streams. Fault diagnostics. You can be having a decision tree that's helping you to figure out what would be the best course of procedure based on the diagnostic that you're getting from the various ways that you're given from information of, say, like a automobile engine, how it's maybe misfiring. You can be doing load forecasting, and this would be getting into how you're looking at how well a factory is operating. You can be using this for control and automation, optimizing the resources that you have at hand, looking at the metrics, and then feeding back and giving recommendations of what to optimize and what to minimize. And finally, giving business intelligence. You can be looking at the publicly available information and helping you make better decisions. Is this a better decision to buy or to create on your own? Different types of things that could be come up. In terms of data representation, I'll get to this in a minute, but I think what I'll do is I'll take another break and then we'll have finished this section up.